at the physical and chemical properties of alkanes. Okay, so first of all, you know that alkanes are also known as paraffins, and also they naturally do not like reaction. Okay, they are already stable, but even though they are stable, but they can still undergo some basic reactions. Okay, so now before we look at the chemical properties of alkanes, first of all, you know that alkanes are, in terms of physical properties, if you look at the alkanes in terms of physical properties, you notice that the first four members of the alkane are gases, right? Methane, ethane, propane, and butane are gases. Then from the C5, from pentane down to heptadecane are liquid at room temperature, right? Then above 18, that is C18 and above, are waxy solid. Okay, so that is the number one property. Alkanes are let's list it out for you. The first property, physical property, is that from C1 to C4 are gases, right? Then from C5 to C17 are liquids, right? Then from C18 and above are solids, waxy solids. So number two physical property. We're looking at the physical property. Number two is that alkanes are soluble in non-polar solvents. Now, alkanes are actually non-polar. Alkanes, they are non-polar. Okay, they are non-polar, and hence they can only dissolve in non-polar solvents. Non-polar solvents. A good example of a non-polar solvent is benzene. Okay. We also have tetrachloromethane. These are all organic solvents. Okay. Number three is that alkanes, their density increases as their molecular weight increases. So, okay, density increases as the molecular weight increases. Okay, so when we talk about the molecular weight, we're talking about the number of carbon atoms, right? As the number of carbon atoms increases, their molecular weight or their density also increases. So how dense an alkane is depends on the word molecular weight. The heavier the compound, the higher the higher the number of carbon atoms, or the higher the molecular weight, right? So number four is that boiling point increases as molecular weight increases, right? So as the molecular weight increases, the boiling point also increases, right? Good. Now, the next one is that branching lowers the boiling point. Okay? Branching lowers the boiling point by what? Creating a large surface area. Okay? So alkanes that are branched, alkanes of the same molecular weight, okay, have branching lowers the boiling point of that alkane. If you are comparing two isomers, for example, let's look at butane. Let's talk about butane and 2-methyl-propane. Butane and 2-methyl-propane. Remember that both of these compounds, their molecular formula is C4H10. Okay, they have the same molecular formula, but their structure is different. These are all chain isomers. Remember, we talk about skeletal isomers under isomerism. So if you notice, the difference between these two compounds is that this one has a branch. So because of the branch, the boiling point of this one will be lower than the butane. Okay, the same goes to pentane. When we talk about pentane, we have isobutane, we have neopentane. Okay, neopentane. Now, consider pentane does not have any branch. Okay, this is 1, 2, 3, 4, 5. This is pentane. But isobutane is one of the isomers of pentane, which is isobutane or isopentane? Sorry. So it is isopentane, not isobutane. Okay. So this is isopentane, right? Isopentane is the same thing as 2-methylbutane. Isopentane is the same thing as 2-methylbutane. Actually, 2-methylpropane is isobutane. So if I'm to replace this, this is also called isobutane. This here is also called isobutane. So, but I'm not talking about that. I've already explained the fact that the boiling point of butane is higher than 2-methylpropane or isobutane. Why? Because butane does not have any branch, but isobutane has a branch. Okay. Now, pentane, isopentane, and neopentane. This represents pentane, right? Then isopentane is just a pentane that has a branch, one branch. Okay. Then for neopentane is simply this. Okay. So look at this. You will notice that this one has more branch. That is neopentane. Neopentane has more branch. Look at the first branch, look at the second branch. But isopentane has only one branch. But pentane does not have any branch. All of them have the same formula, C5H12. Okay? So because of that, if you are told to arrange these three in order of decreasing or increasing boiling point, you will see that the boiling point of pentane will be higher than that of isopentane, followed by neopentane. So the one that will have the lowest boiling point is neopentane. Why? Because it has more branches, followed by this, so it has only one branch. But this will not have the boiling point to be higher than this because this guy does not have any branch. So the end point of this is to know that branching lowers the boiling point by creating a large surface area. Okay, picture this as, what is surface area? For example, picture it this way. If you are told to take a drug, let's say paracetamol tablet, and somebody swallows that tablet like that without grinding it, and some other person grinds the tablets, grinded their paracetamol, that's the paracetamol that I swallowed, grinded it, dissolved it in water, and still took the drug inside. Now, the difference between both of you is that, now, between two of you, the person that swallowed the pill without grinding and the person that grinded the pill by taking it, which one will react faster to the body? The one that will react faster to the body is the person that grinded it. Why? Because once you have grinded that drug, you have exposed the surface area. So the active size of that drug has been exposed. So when you take that drug, it will react faster immediately. That's the same way the surface area happens here. So if the surface area is large, the molecule will it will not take time for it to start boiling because the molecule has already been exposed. But if the surface area is small, when you heat the compound, that heat will first of all liberate the surface area so that it can now heat up or boil. So, but when you have a compound that the surface area is already exposed or large, it won't take time for that thing to boil. So the surface area, if a larger surface area increases the boiling point, decreases the boiling point. A larger surface area decreases the boiling point, so it takes time for it to boil. But if the surface area is very small, it takes time for it to boil. So branching increases the surface area and decreases the boiling point. Okay? So that is why we justify that pentane does not have any branch. So definitely the boiling point will be higher than this and than this. Okay? So remember, all we have talked about here is just the physical properties. Okay? There are more we can talk about, but we are going to end it here with just these 5 physical properties. So when we talk about alkane, in terms of physical property, we are referring to them as those ones that we can actually see with our eyes. So the next we talk about now will be the chemical properties of alkane, or you can call it reactions of alkane.